Hello everybody! In this new video tutorial we will see different communication systems between an exam and a ctrlX core. The objective in this case are as follows. Use the cyclic communication module AEL TCP cyclic. Using network variables using UDP. Use the cyclic communication module AEL UDP cyclic. All the examples that we are going to see are made in letter format to facilitate the visualization of them. Although obviously this can be done in the language that each one considers most appropriate. Communication with AEL TCP cyclic. The procedures for managing sending and receiving data are quite easy. The libraries to be used in the different PLC are the following. For ctrlX core or ctrlX drive with core, the library used be CXA socket.com, and for the XM, the library will be RAEL socket.com. In any case, and regardless of the library, the module to be used in both PLCs will be the AEL TCP cyclic module that will also allow us to select between server or client. Overview of module inputs. AEL TCP cyclic. Enable activates the communication module. Mode. It allows us to select the operation of the module. At first, and to make communication more fluid, we will use the first two options depending on whether the devices server in ctrlX core or client in XM IP address. Here we must place the IP of the device with which one to connect. Port. Address of the port to be used. Default 50,000. With this value in both places, the system in TCP mode communicates without problems. Send. This input is not used if we are working in either of the first two modes of operation. Send data ADR. Data to be sent in pointed format. We must use the ADR statement to define the memory area used. Receive data ADR. Also in this case you must define with ADR statement the memory area used to receive the data from TCP communication. The following two instructions with the use of sizeof allow us to define the length of the memory entered with the ADR instruction, which allows us to adjust the frame of sending and receiving data. Finally, we have the waiting time that at first we will not touch, but that obviously we can adjust later. Description of module outputs AEL TCP cyclic. In operation, this output, if it is active, indicated that there is data transfer. Error. It is indicating that an error has occurred in the module. Error ID. Indicator of the existing error class. Error ident. Detailed error information. Status. In the attached table, we can see the different messages that may appear. Response time. Here we can observe the sending, reception cycles and the time used for them. Don't send. Successful sending confirmation. Don't receive. Successful receive confirmation. The state allows us to know how the system is, even so the program should be prepared to try to rearm automatically to avoid connection problems so that we are always connected, if the conditions are correct. List of possible communication module error codes. Let's see how the example program has been made. First, we can see the structure used in the example. Since we only intend to see how communicator works, we have generated two structures with a simple configuration of values in Word format. Obviously, these settings can be modified to adapt the data to use of a specific application. On the other hand, we also have the variables used for the control of the communication module. The enable bit, the receive and send pointer, the numerator that allow us to select the server or client mode, the blink from the start of the communication, and finally the control FB for the communication using TCP cyclic. The first line of the example program contains the blink that we use to control the restart of the communication in case of communication loss or problems in the boot and even in the same module. In this way, and with the help of segment 2, we are always trying to start the communication by activating the be enabled bit. In the third segment, we assign the value to the numerator, in which we will indicate the operation of the module that in this case will be the server, since the ctrlX will be used as a server. The next segment is the communication module itself, which included the IP address of the XM and the pointers associated with the sending and receiving areas. Finally, we have a value counter that will send data to the XM so that we can verify that the communication works without problem. At the level of structure and variables in the XM, if we do it right, we can use the same ones that we have used in the ctrlX, since exactly the same is used for the operation of the system. However, in order to not have errors, the names of the structure have been modified, since in this case they are sent and received from the ctrlX, and in the ctrlX they were sent and received from XM. The only difference is the FB instant definition AEL TCP cycle. This case refers to communication with the ctrlX core. This also applies to the code, as it works exactly the same as in the case of XM. The only change to take into account is the assignment of the numerator, this time using the client model, and of course the IP address that moves now corresponds to that of the ctrlX core. Also in this case we use a counter to send data to the ctrlX core. In the following example video, we can see the operation of the system. Communication with network variables. CodeSys also enables communication using specific variables of sending and receiving over the network. As we can see, in boot PLC appears the network variables list as receiver. The tables of variables in this case are identical to those used in the previous case. Even so, and since the variables use some files for the integration of the same in the other PLC, we have changed the name to make the data user clearer. So in this way, the indicator shows us the direction in which the variable moves out of the ctrlX core and reaches the XM, and on the contrary leave the XM and reaches the ctrlX core. In this way, the structures are exactly the same in both PLC. Description of the parameters used for the communication of the variables to be sent. At first, we leave the option as they appear in the image. The communication should work without problems. The only one that should be taken into account is the parameter list identifier, that should be different in each of the transmission lists. We will start first by configuring the list of variables to send from the ctrlX core to the XM. The communication in this case is always UDP. At the moment we enable this, we can access the setting screen where we can select the port number different for each list of communication variables and the IP address of the PLC with we want to communicate. In this same table of variables later, we will generate the variable to be used by the communication from this structure that we have previously prepared. Now we will repeat the operation in the XM, taking the precaution as we have said to modify the list identifier, the communication port, and of course the IP address of the device with which we want to communicate. Obviously, we will also generate the variable from the structure defined above. As I say, it is important to program this step because if not, we will not be able to activate the reception data. Since first, we must generate the files that will allow us to link both PLCs. In the case of ctrlX core, the file is generated in this way, and once generated, we can see the variable used, the identifier number, the port, and the IP used to communicate. For the XM, we will do the same and generate the file that we will use later in the ctrlX core. In this case, we can see the same data as in the case of ctrlX. Only that obviously the variable used is different, and that of course, as we have already mentioned, a list identifier must be different. In this case, the number 2 and the port is now 1203 and the IP that of the ctrlX core. We return to the ctrlX core and incorporate the list of network variables importing the file generated by the XM, which will insert the created communication variables. From this point, we cannot modify in any case the table of variables since it comes from the other PLC. Now we repeat the same with the XM using the file generated by the ctrlX so that the table of variables is generated, which as in the previous case cannot be modified. When using network variables, the system itself generates the automatic instantiation of some of the functions so that they already appear in the variable table itself when they put in online. In the image, we can see the two communication tables generated in the ctrlX core, the sending and receiving. In the case of XM, the behavior is exactly the same, and in the same way the instantiations are generated automatically. As additional notes to keep in mind, it is important to note: use a different list identifier for each of the sending groups. In the table of sender variables and in the settings part, you must define a different port and enter the addresses of each of the devices with which you want to communicate. If we keep the default IP address, the communication in some cases only works in one direction. In this image, we can see the data sent from the XM to the ctrlX core. And in this order, the value is sent from the ctrlX core to the XM. Communication with AEL UDP cyclic. The module that we are going to use is in the same library that we have used to TCP communication. In this case, the module to be used will be the AEL UDP cyclic. This module is identical to one used for TCP control signs at the level of input and output parameter. It is exactly identical. The only thing that we will have to modify will be the instance of the new modules so as not to degenerate problems with the names. In the ctrlX, we modify the names of the communication blocks and use it to the module AEL UDP cycle. And at the XM we do the same, modifying the module name and also using the module AEL UDP cyclic. However, in this case and only in the XM, we must incorporate the following variables that will allow us to perform a control to activate the AEL UDP cyclic block in some circumstances that do not occur in the EL TCP cyclic. The added lines that affect activation control of enable in the case of using AEL UDP cyclic are as follows. The first activates the bit for reading the pin control module. This is done to check that the ctrlX is connected and ensure that we have the communication established. Using AEL UDP cyclic, it has been observed that if in the ctrlX core is not activated before activating the communications module, the communication does not seem to work. That is why the use of these three new segments allow the start in any circumstances. The second segment contains the if be used to check the IP of the ctrlX core and thus ensure that communication is established. Likewise, when the communication has been established, a timer is activated to this connection that allows us to ensure the activation of the enable of the communication in the same way that we did using AEL TCP cycle. Keep in mind that IP test works with an activation signal of the type execute, so that is why we are using a constant flag of this input signal and the delay to disconnection. Finally, the timer contact is placed in series with the activation signal of the enable. Additional notes. Each of the system has its peculiarities. UDP is usually faster in terms of transmission speed. TCP is more reliable because data is delivered correctly. UDP can deliver incomplete data. Using the neighbor variable list UDP, you can enable controls such as the transmission of the checksum or the acknowledgement to the datasend. In short, if we are going to use any of these systems, we must be clear about the one that best suits we want to do. Thanks for your attention.